Hey guys, what I'd like to do quickly with this video is run through those few functions of the absolute values, those graphs I asked you to look at and compare and contrast. So to start off with, we're just going to look at the initial graph, the function of x is equal to the absolute value of x. So remember that we know that the absolute value of a number only deals with its distance away from zero. And because we are dealing with how far the distance something is from zero, our answers are always going to be positive. You can't have a negative distance. So that's why absolute values, we always take the positive number and express our answer as a positive, because distance can only be positive. So that helps explain why the shape of this graph becomes a nice V, that the absolute value of -2, well, how far is -2 away from zero? It is a distance of 2 units away from zero. So that's why we get a value on our absolute value graph at being 2. Some key features to note: that when when we're looking at a positive absolute value, our arms are up, they're pointing up. And when we've got just the absolute value of x, our sharp point is down here, and our sharp point happens when the thing inside the absolute value symbols, in this case x, is equal to 0. So whenever the thing inside the absolute value equals to 0, that's where our sharp point is going to occur. So hence why it's occurring at 0 here. So that's pretty much our basic features of an absolute value graph. It's straight lines everywhere that come to a sharp point, and that where that sharp point is located is depending on when the thing inside the absolute value is equal to 0. For this graph here, it's domain. So what x inputs are we allowed to put in? Well, there is no x input that we can't put in. So we say that our domain is all real x, or from -infinity to +infinity. And remember, we use curved brackets here because infinity isn't actually a number, it's an idea, it's a concept. Its range, so in other words, is once we put an x value in, what do we get out of it? Well, our range of values here, we can see that the lowest value it's ever going to take on is 0. And 0 is a physical number, and it's actually at 0. So we use a square bracket, 0, and it goes all the way to +infinity. So its domain is x belongs to the set from -infinity to +infinity, and the range belongs to y belongs to 0 up to +infinity. So let's go on and start comparing some different graphs to it. So the first one we're going to compare is the graph of y equals negative absolute value of x. And one thing to notice here is that the sharp point is in exactly the same location. And it's exactly the same location because when does the absolute value of x equal 0? Well, that's when x is equal to 0. So that's why our sharp point's there. But the interesting thing is this negative symbol at the front of our absolute value symbol. So if we think about orders of operations, take the absolute value of any number, it's going to give us a positive answer, but then we need to multiply it by -1. So if we look back earlier, I said the absolute value of -2 is 2, but then I multiply it by -1, and that's why we end up with, in this graph, all our answers are below the x-axis because that negative is outside of the absolute value. So because there's a negative at the front of the absolute value, our arms are going to be pointing down. So now that we've looked at that key feature, where that sharp V point is, it's at x equals 0. The negative at the front makes our arms go down. Let's talk about its domain. Its domain, well, it's the same as the previous absolute value. There is nothing stopping me putting any x into this. So x belongs to negative infinity to positive infinity. But this time, because it's reflected around the x-axis, it's negative. Our lowest value is negative infinity for our range, and it comes all the way up and stops at 0. So we use a square bracket there. So y belongs to the set between negative infinity and 0. Hope that's okay so far. Any questions, flick an email and I'll try and get back to you with something soon. Let's compare now. Let's start moving this graph around a little bit more. So we're looking at the red graph here, which again, it's going to be on everything we look at, which is just our absolute value of x. And we're going to compare that towards the negative absolute value of x plus 7. So I think a couple of key things to notice here is where our sharp point is initially. It's still at x equals 0. But one thing to notice is our whole graph, everything has been moved up 7 units. If I take the absolute value of negative 2, the absolute value of negative 2 we know is 2. Because there's a negative sign out the front of it, that keeps it as negative 2. And when I add 7, that's going to equal 5. And when we look up here, that spot there is actually 5. So this random plus 7 at the end has caused our entire graph to shift up 7 units. Every single point anywhere on this graph has now moved up 7 units from just our normal negative absolute value graph. So that random constant at the end has the impact of shifting our graph up 7 units. So now that we know our sharp point has been shifted up 7 units and we know where it's at 0, let's talk about its domain and range again. Well, again, its domain is going to be x belongs to negative infinity to positive infinity. And when we look at this, because it's the negative value of absolute x, our lowest value is negative infinity. But because we've had that plus 7 at the end there, it's shifted our range, our whole graph, up 7 units. Its maximum value is 7 units. And again, we use that square bracket because we can be exactly at 7. So hopefully you've noticed that random constant is moving our graphs up and down. If we look at our next example here, the absolute value of x plus 4, well, very similar to the last one. Let's look at the sharp point. Again, that's when the absolute value of x equals 0, so its x coordinate is 0. But this plus 4 has just moved it up 4 units. So it's the exact same value as the graph as the absolute value of x. It's just been moved up 4 units courtesy of that plus 4 at the end. So now that we've seen that, let's talk about its domain. Well, its domain is negative infinity to infinity. There's no x value I'm not allowed to put in. But our y values, well, the lowest value it can take on is actually positive 4, and the greatest value is infinity. And again, remembering to use our square and curved brackets to indicate inclusive or not inclusive. Hope that's fine. Keeping on, moving on. Let's notice, well, here we're going to look at the absolute value of x plus 7. And one thing to notice here is now that we've got a plus 7 inside the absolute value, let's look at what's happened to the sharp point. When does the absolute value of x plus 7 equal 0? Well, that only happens when x is equal to negative 7. So by putting another value, another constant inside the absolute value symbol, what has the impact is shifting the graph left or right. So earlier we looked at that random constant at the end outside the absolute values moves the graph up and down. Here, when we add or subtract something from inside the brackets, it's moving it left and right. We've seen that before when we've factorized parabolas. So just quickly remember, if we go to this one, we know that that factorizes to x plus 3, x plus 2, and we're using that same idea, and because it's x plus 3, x plus 2, our parabola has its zeros or its roots at x equals negative 3 and x equals negative 2. So that's a parabola that's moved left of the y-axis because we've got the x plus 3, x plus 2 inside brackets. We've got the same situation happening here but with the absolute value symbol. So we've moved it left. There's no constant outside, there's nothing outside, so it hasn't shifted up or down, and we can see that. So going through the domain of this one, its domain is x belongs to negative infinity to positive infinity. And y, well actually y has a minimum value. Y's lowest value is 0, and that stretches out to positive infinity. Hope that one's okay. Again, if any of these are not sure, if you've got any questions, please email me and I'll respond as soon as possible. Again, now looking at something where we've got then y is equals to the negative of the absolute value of x minus 3. So I think, again, the main thing to focus on to begin with is where is that sharp point. And that sharp point now has the location of the coordinates of, not 0, it has the coordinates of 3, 0. And that's because the absolute value of x minus 3 is equal to 0 when x equals 3. So again, this random putting something inside the absolute value symbol has made our graph shift, and in this case it's shifted to the right, and it's shifted 3 units to the right. As we saw earlier, this negative symbol out front, that just causes our graph to be both arms down compared to our normal absolute value of x. So quickly running through its domain, I guess you guys have started to notice the trend with its domain. All the domains go from negative infinity to positive infinity with absolute value graphs, but our range kind of stops and starts depending on where our sharp point is. So its lowest value is negative infinity and its highest value is 0. Hope that one's okay. Moving on to our last one here. So we're having the absolute value of x compared to the negative absolute value of x plus 5 plus 4. So there's a lot going on with this one. So again, we always start looking at where is the sharp point located. And the coordinates of the sharp point are negative 5, 4. So let's focus on why is it negative 5. Well, the negative 5 part comes from when does the absolute value of x plus 5 equal to 0, and that happens when x is negative 5, because we've got that random plus 5 inside the absolute value. This whole graph has been moved up 4 units, and we know that that up 4 units comes from that random plus 4 that's outside, it's tacked at the end, it's that random constant at the end. And finally, we've got both arms down because there's that sneaky negative out the front. So we can see that the plus 5 inside the absolute value moves the graph to the left 5 units, the plus 4 on the outside moves it up 4 units, and the negative on the outside of the absolute values makes both arms point down. So its domain is negative infinity to positive infinity, and its range is negative infinity up to and including 4. So just to recap quickly, the most important things to think about when we are looking at the absolute value graphs is where is that sharp turning point. not turning point, sorry, if I was just to quickly sketch one down the bottom here. So if I was just to quickly sketch in that absolute value, the most important thing to look at is, well, where is our sharp point? How is that sharp point being moved? Has it been moved up? Has it been moved down? Has it been moved left? Has it been moved right? Remember that left and right, that comes when you've got x plus some random constant or some random value inside the absolute value symbol. Oh, let's undo that. Up and down comes from when you've got some random constant on the outside of your absolute value symbol. Hope that helps explain some of the shifts and movements of the graphs of absolute values. You're going to be expected to know and be able to describe how an absolute value graph or function has been moved around on a number plane, how it's been shifted. Hope that helps, guys. Again, if it doesn't, email something through and I'll do my best to get back to you as soon as possible. Cheers.